What is going on, guys? Welcome back. In this video today we're going to implement a compound interest calculator in Python. So let us get right into it. Now before we get right into the coding, I would like to show you what we're going to end up with here today as a motivational preview up front so you know what's coming. And this is going to be the final result, the compound interest calculator here as a web application. What we can do here is we can define the initial deposit, so the principal amount. Let's say we have 10,000 US dollars that we want to invest. Then we specify the expected interest rate, so let's say 5% annually. That would be 0.05 here. Also, we can define a contribution, so a monthly contribution of $100, for example, meaning we're going to add to the initial 10,000 and to the stuff that is compounded from these 10,000. We're also going to add $100 every month, and these are also going to be compounded, but in a different way because, of course, the different pieces or the different instances of these contributions, of course, get compounded for different time frames. And then we're going to specify also a compounding type, so monthly or annually. And then finally, we can say we want to do this for 5 years. When I click on calculate now, we get a couple of things. We get, first of all, the final amount with interest. So this is what we have after 5 years. Then we can also see here the difference from contributions without interest. So this is the difference. How much more money did we make because of the compound interest? And then you also get a graph down here showing how much money we would have made just by contributing $100 for 5 years and having the 10,000 to begin with. And then we see with the blue line here how much more we have now because of the compound interest. And of course, we can do the same thing here for 50 years. Then it's going to be even more extreme. As you can see, this is growing quite quickly. So this is what we're going to build in this video today. Alright, so I'm going to split this video into 2 sections because some of you guys might only be interested in doing the raw calculations. So all you want to do is you want to have a Python script where you define the parameters in the beginning, then you run it, apply a formula, and get the result in the command line. If this is what you came for, you're going to find it in the first section. In the second section, I'm then going to build a Flask application around it. So we're going to work with HTML, with forms, with endpoints. It's going to take a little bit more time, and we're going to end up with what you saw in the preview. So for those of you who are only interested in calculating the compound interest, you can watch the first section and then stop. For those of you who want to build a calculator as a web application, you can watch the full video. So in order to just get, in order to just do the calculation, what we're going to do is we're going to define the parameters. We're going to say the initial deposit is going to be equal to 10,000. We're going to say that the interest is going to be equal to 0.05, so 5%. The contribution, the monthly contribution, is going to be equal to 100 per month. The compounding type is going to be equal to monthly. Now, of course, you can change all of these values. And finally, the time period is going to be equal to 5 years. Now, maybe we should call this time period years equals 5. Now, the calculation of the compound interest is obviously based on a formula. I'm not going to explain how to derive this formula. One part is quite simple. You just apply compounding interest onto a static initial deposit or onto a initial deposit that, of course, grows, but you just have to compound it. The second part is a little bit more complicated because you have to compound monthly contributions. So you get a geometric series that you have to then simplify to the final formula. I'm not going to explain how this is done exactly, but I'm going to show you the final formula. But first of all, we need to say that we're going to have a parameter n in the formula, which is how many times per year do we compound the money. And this is going to be 1 if it's annual and 12 if it's monthly. So we're going to say if compounding type is equal to annual, n is going to be equal to 1. Elif compounding type is equal to monthly, then this is going to be equal to 12. All right, so in order to just compound the initial deposit for 5 years with a 5% interest rate, that is done quite easily. You just say total amount is equal to, you take the initial deposit and you multiply it by 1 plus interest rate divided by how many times you want to compound it per year, so divided by n. And then you take that to the power of how many times per year you compounded. So n times how many years you do that, or for how many years you do that. So this is going to result in just compounding the value for 5 years. Now, this is easy because the initial deposit, all of it is done, or all of it is compounded for 5 years. With the contributions, it's a little bit more complicated. So with the contributions here, we have to apply the following formula: contribution times, and then basically we have to say 1 plus interest rate divided by n. This is then taken to the power of n times time period years. But from this then we subtract 1, and then we divide this by the interest rate divided by n. So this here is going to be in the denominator. Now let me just check the parentheses here. So we have this, and I'm not even sure if that's necessary, but let's just add an additional bracket left and right. But I think that should be the correct formula. Yes, so we do the same thing as here, but we then subtract 1 from it, and we divide it by interest divided by n. Again, this is just a result of taking the sum of the geometric series. You can look it up if you want to know more details, but this is how you compound the contributions. And the final amount is then just final amount is equal to total amount, so the initial deposit compounded plus the total contributions compounded. That is going to be the final amount. So in this case, we get 19,634 point something. So we have to round it, of course. But this is how you do that just as a script. So if that's what you came for, this is it. You just define the parameters, you apply the formulas, and you get the final amount. Now we're going to take all of this and turn it into a Flask application. So we're going to say app.py. Now for this, of course, you need to have Flask installed. So if you don't have Flask installed, you're going to open up your command line, pip3 or pip install Flask, like this. I don't think that we're going to need anything else. Oh, actually, we are going to need something else because, of course, we're also plotting the difference. So we're going to say pip3 or pip install matplotlib as well. And once you have these installed, we're going to start by coding our application. So we're going to say from Flask import, let me just zoom in a little bit, import Flask with a capital F, render template to be able to render HTML files, and request to be able to handle forms or post requests. Then we're also going to say import matplotlib, or maybe let's do it the other way around. Let's say import matplotlib.pyplot splt first. And above that, some core Python imports, import IO, and import base64. These three packages here are only relevant for exporting the graph and showing it in HTML or in the templates. Then we're going to say the app is going to be equal to an instance of Flask __ name __. We don't need to specify the template directory manually. We can also just use templates by default. So we're going to create a templates directory here. And what we're going to do now here in the index, we're only going to have a single endpoint, which is going to be app route /. But this route is going to support two different methods. It's going to support get and post. So I think we need to say methods equals get and post. And it's going to be the same endpoint. So by getting, we're going to get the form, and by posting, we're going to get the result with the graph. And we're going to basically check if the request.method is equal to post. Then we're going to do one thing, and otherwise we're going to just render the index HTML file. So we're going to return render template index HTML file that we don't have yet. So we're going to say index, actually let me use the template here, index HTML. We can call this compound interest calculator. And what we're going to do here is we're going to have a form, or first of all, let's add a heading. Let's say compound, actually this is with D, not T. Compound interest calculator, and then we're going to have a form, This form is going to have the method post. The action of this form is going to go to slash, so to index. And in this form now we're going to have all the values that we need. So we're going to say label for initial deposit is going to be initial deposit. Then we're going to have a line break. And then we're going to have an input with type number with ID initial deposit with name initial deposit and with a step of 100. So this means that when you click on plus or minus, you're going to increase or decrease by 100. And we're going to say that this is required. So actually, maybe for the initial, or actually, let's keep it at 100. So that is the initial deposit. Then we can copy that. We can paste that. We can do the same thing for the interest. Actually, interest rate. Interest rate. Interest rate. And here the step size is going to be 0.1 or 0.01. Again, just copy paste this. So take this, maybe do it 2 more times. So we're going to say contribution is the next one. Contribution. Contribution. Actually, I can use the Vim bindings here. And finally, we're going to also need the time period. In between, we're going to have also the compounding type. So I'm going to say here now that this is the time period years. Let's do it here as well. And then here, time period in years. The step size here is going to be 1. And for the contribution, it's going to be 10. And in between here, we're going to have a select. And it's going to have a couple of options. Now, we still need to have a label here. So it's going to be for the compound type. Compounding type, we should say. So that is going to have the ID equal to compounding type and the name equal to compounding type. I think the ID is for the label and the name is for passing it to the form. This is why I specify both. So I definitely know that the name is what we use in the app. Then I think that for a label you need to have ID, but I'm not a big fan of HTML, so I don't know if that's true. And in this case here also we want to have, or actually we don't need to specify required. We can just specify 2 options here. Option is going to be monthly here, and the value is going to be equal to monthly. And then we're going to say annually. All right, and finally we need to have a submit button. So input type is equal to submit, value is equal to calculate, and that should be it. That should send a post request to our app that we can handle. And in our app now we're going to do all the calculations. Now for this we can actually copy. Actually, we should be able to copy all of this. So I'm gonna just do it. Now, of course, instead of defining the values, we need to get them now from the form. So we need to say float of request form and initial deposit. And here now I need to do float request form interest. I think I called it interest rate, right? Yeah, interest rate. Maybe let's call it interest rate here as well. Then float request form contribution. Float request form compounding type. And then float request form time period years. So these are just the values that we get from from the post request. And then we're going to say that, yeah, basically the same idea. We said n depending on if it's monthly or not. We can actually make this a one-liner. Let's say it's 12 if n, actually, let's say n is equal to 12 if compounding type is equal to monthly, and else it's 1. I'm just going to say if it's not monthly, it's going to be annually, no matter what you pass. And then we're going to do the same calculation. So total amount is going to be interest rate, and interest rate here again. Also here, interest rate. So the same calculations as we saw in the script example. And we also have the final amount. But what we need to do now is we also need to, for the graph, so that we have the comparison graph, is we need to go through all the individual years or instances of compounding, or actually just years. We need to go through all the years, and we need to compare the amounts if we don't compound and if we do compound. So I'm gonna call this here actually final amount with interest. And then we're going to say that the total contributions without interest are going to be equal to the initial deposit plus obviously the contribution times how many times we're going to contribute. So time period years times how many times we compound. So that is without interest and with interest. So we can also calculate the difference. The difference is just going to be final amount minus total contribution. So this is enough for a comparison already, but we also want to have it in between. We don't want to just have the comparison in the end. We want to have it at every single year. And for this, we need to actually iterate over the years. So we're going to say here amounts with interest is going to be an empty list. Then amounts without interest is going to be an empty list, and then years is going to be equal, or actually I can just do it like this, for year in range time period years plus 1, or got float instead. Yeah, this is because this needs to be an integer. But besides that, this should work. So we go through every year, and then we basically do the same calculation that we did before. So we just do, let me just double check here. We do this, year's contribution. Yeah, so we basically, we copy this here to calculate it for the specific year. Now it's important that here we now go with year and not with time period. So we just go year and year. And then what we do is we say total, or I should also change the names here to not overwrite the values. So year amount, year contributions, or let's say year total amount, year total contributions, and then year total contributions without interest, which is going to be the initial deposit, plus contribution times year times n. And then what we want to do is we want to say amounts with interest, append year total amount plus year total contributions, and then amounts without interest, append year total contribution without interest. All right, and once we have this, the final thing is we need to just create a figure based on that. So we're going to say PLT figure. The figure size is going to be equal to 10 and 5. And then we're going to plot 2 lines. So we're going to say PLT plot. Now on the x-axis, we just need to have the years. I think that since this is a range, we need to turn it into a list. Oh, no, sorry. We need to say this is going to be list of range of time period plus 1. maybe it makes sense to say, let's do it like this. Years is going to be equal to list range time period years plus 1. Then replace this here with years. And here now we can also just specify years as the x values. And then we're going to plot the amounts with interest. We're going to say that we want to have a marker at each point, which is going to be a circle, so an O. And the label for this, for the legend, will be with interest, like this. Then the same thing will be done for without interest. And the title of our plot will be compound interest over time comparison. PLT_X label will be years. PLT_Y label will be amount, let's say, in dollars. And then PLT_grid will be enabled, so we're going to set the grid to true, and we're going to say PLT_legend, so that we have a legend, we know which one is with interest and which one is without. Obviously, the higher one will be with interest if it's a positive percentage. And then what we need to do to actually make this possible, or to make it possible to show this in HTML, we're going to say image is equal to IO bytes IO. And then PLT save figure. We're going to save this into image as a PNG format. So format is going to be equal to PNG. Then we're going to say image seek 0 to put it back to the initial position. And then we're going to say plot URL is going to be equal to base 64 B64 encode image.getValue. And whatever we get here, we just decode. That is going to be our plot URL. And then finally, we're going to say return render template. And now we're going to need a second one, which is going to be an HTML file called result.html. So we're going to return that, and we're going to pass a couple of parameters. We're going to say final amount is going to be equal to final amount with interest. Difference is going to be equal to difference. And then, of course, the plot URL is going to be equal to the plot URL. So we're almost done now. The last thing that we need to do is we need to implement the final HTML file. Here now we're just going to say calculation results. Let's also add a simple heading, calculation results. We're going to say that the final amount with interest is going to be equal to $, and then we're going to use the final amount. I think this is what we passed here, right? Final amount, yes. Then we can say what's happening now? Oh, there you go. Difference from contributions without interest. Actually, let's do all of this in lowercase. That is going to be not the final amount, but the difference. And then finally, what we want to show is we want to show the growth over time, or let's say difference and growth over time. I'm using uppercase here again. And here now we want to have an image where the source is data : /image/ or actually : image, and then /png, semicolon base 64, comma, and here we pass the plot URL. So that is just going to render our image here, and we're going to say the alternative, if it doesn't render, is chart or something like this. All right, and finally, the last thing is I want to also have a back button. So I want to say we want to have here a going back to index, which just says back. And then we just run all of this, and we hope that it works, that we didn't make any mistakes here. So if name equals main, then we're going to say app run, debug is going to be true, And that should be it. So I'm going to run this now. I'm going to open it. And we do have a problem, which is just a styling problem, which is that I forgot to add, it's a little bit laggy here right now. I forgot to add these line breaks. So I think that we need to have 2 line breaks after each of these for this to work properly. I think this is how we do it here. So let's rerun this. And there you go. Okay, so let's do it again. 10,000 initial deposit, interest rate of 0.05, contribution of 100 per month, monthly compounding, and we want to do this, let's say, for 10 years now. Calculate, and we have a problem. Could not convert string to float. Yes, this is of course because we don't want to convert this to float, so we're going to remove this here because that is a string, obviously. So let's try it again. Calculate, and there you go. This is the final amount. Now what we should probably do here is we should round this. So we should go to final amount and use a pipe round to, and for the difference as well. Let's see if that worked. Recent, there you go. So now we have the final amount, we have the difference, and we have a chart showing us how the difference develops over time. So this is how you can build a simple compound interest calculator in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.